Australia may be sitting on a forgotten petroleum province containing more than 31 billion barrels of oil, not offshore and not beneath the Northwest Shelf, not in the famous Cambrian Basin, but beneath a vast inland basin stretching across western Queensland and the Northern Territory, a basin larger than the United Kingdom, Italy and the Philippines. A basin containing world-class source rocks, giant structural traps, intensive carbonate reservoirs and one of the most unusual petroleum systems ever identified in Australia. Because unlike most of the oil provinces we've discussed on this channel, this oil didn't originate from forests. It didn't come from coal swamps or ancient river deltas packed with vegetation. Instead, it formed from microscopic organisms living in tropical seas more than 500 million years ago. This is before trees existed, before dinosaurs, before plants had even colonized the land. Yet, despite containing all the ingredients needed to form major petroleum accumulations, only around 60 petroleum wells have ever been drilled across the entire basin. That's not 60,000 and not 600, 60. The question isn't whether hydrocarbons formed here. The rocks prove they did. The question is whether one of Australia's largest undiscovered petroleum provinces is still waiting to be found. The Georgina Basin doesn't look like an oil province. If you stood in the middle of it today, you would see endless plains stretching toward the horizon. Red dirt, spinifex, sparse vegetation and remote cattle stations. A landscape so empty that it's difficult to imagine anything of significance hidden beneath it. Yet appearances can be deceptive. Because beneath this seemingly featureless country lies one of Australia's largest sedimentary basins. The Georgina Basin covers approximately 333,000 square kilometres across western Queensland and the eastern Northern Territory. The scale is difficult to comprehend. If you placed Victoria inside it, there would still be enough room left over for Tasmania. Yet despite covering an area comparable to entire nations, most Australians have never heard of it. And perhaps even more remarkably, petroleum geologists still don't fully understand what may be hidden beneath it. The reason is simple. The basin contains all the ingredients needed to generate hydrocarbons. The source rocks exist, the reservoirs exist, and so do the seals and traps. And yet despite all of that, only around 60 petroleum wells have ever been drilled across the entire basin. Trying to understand a basin this large using so little drilling is like trying to evaluate an entire goldfield using only a handful of drill holes. You might discover something important, but you will never claim to understand the full picture. And it is why the Georgina Basin remains one of Australia's most intriguing petroleum mysteries. The story begins more than 500 million years ago. And unlike many of Australia's other petroleum provinces, it does not begin in a forest. In fact, there were no forests, no trees, no flowering plants, no grass, birds, mammals or dinosaurs. In fact, if you had travelled to the Georgina Basin during the Cambrian Period, you would have found yourself in a world almost unrecognisable. The first forests were still hundreds of millions of years away. The first trees had not evolved. The familiar terrestrial ecosystems we know today simply did not exist. Instead, much of Central Australia lay beneath warm tropical seas. Shallow marine waters stretched across vast areas of the continent. Sunlight penetrated to the seafloor. Microbial communities flourished. Tiny organisms drifted through the water column. Algae bloomed. Primitive marine ecosystems thrived. And when those organisms died, their remains slowly settled through the water. Grain by grain, layer by layer, year after year. Over immense spans of geological time, organic rich mud accumulated across the seafloor. Those sediments would eventually become one of the most important source rocks in Australia, the Arthur Creek Formation. For petroleum geologists, the Arthur Creek Formation is extraordinary, because unlike many younger petroleum systems, this source rock was not formed from buried forests, peat swamps or vast river deltas. Its hydrocarbons originated from microscopic life inhabiting tropical seas more than 500 million years ago. The oil beneath the Georgina Basin may have originated from organisms that lived before trees had even evolved. That alone makes it one of Australia's most unusual petroleum systems. Studies have documented total organic carbon values reaching as high as 16%. Those numbers are remarkable. Most source rocks are considered good when total organic carbon exceeds 2 or 3%. 5% is excellent. 10% is exceptional. 16% places the Arthur Creek Formation among the richest source rocks identified anywhere in Australia. The implications are profound. Source rocks are the engines of petroleum systems. Without them, no hydrocarbons can form. And the Arthur Creek Formation appears to have been an exceptionally powerful engine. As younger sediments accumulated above it, the source rock was gradually buried deeper beneath the surface. Temperatures and pressure increased, organic matter slowly transformed. The process took millions of years, then tens of millions. Eventually, the source rocks entered the oil window. hydrocarbons began forming, oil was generated. The source rock worked, and that point is critical. There is no debate about whether the Georgina Basin generated hydrocarbons. The evidence is overwhelming. Oil shows have been encountered in numerous wells. Hydrocarbon staining has been observed. Geochemical studies demonstrate that the Arthur Creek Formation generated enormous quantities of petroleum. The system is proven, and that immediately raises an obvious question. Where did all that oil go? And this is where the Georgina Basin becomes particularly interesting, because the basin may contain both unconventional and conventional petroleum resources. The unconventional story centres on the Arthur Creek Formation itself. Modern assessments suggest the basin contains approximately 31 billion barrels of oil in place within its organic rich shales. In this scenario, the source rock acts as both the source and a reservoir. Rather than searching for migrated oil trapped elsewhere, companies drill directly into the shale and attempt to produce hydrocarbons using horizontal drilling and hydraulic fracturing. This is the same basic concept that transformed formations such as the Bakken in North Dakota and the Permian Basin in Texas into some of the world's most productive petroleum provinces. But the Georgina Basin may also contain something else, a conventional petroleum province, because oil generated within the Arthur Creek Formation did not necessarily remain where it formed. Some of it may have migrated into surrounding reservoirs, and directly beneath the Arthur Creek Formation lies the Thorntonia limestone. And that's where the story becomes strange. Oil normally migrates upward through the subsurface, not downward. Yet geologists have identified the underlying Thorntonia limestone as one of the basin's most prospective reservoirs, suggesting that faulting, folding, and lateral migration may have created pathways capable of directing hydrocarbons into traps that would not normally be expected. So overall, to petroleum geologists, the Thorntonia limestone immediately attracts attention, because now all the ingredients of a conventional petroleum system are present. The Arthur Creek Formation acts as a source rock, the Thorntonia limestone provides the reservoir, the overlying Arthur Creek shale provides the seal. Everything is stacked neatly on top of each other. The ingredients are already assembled. All that remains is determining whether hydrocarbons accumulated in economic quantities, and there are plenty of places where they could be hiding. The basin contains large structural faults, fault rollovers, fault-bounded traps, stratigraphic pinchouts, porous dollarstones, and hydrothermal dolomite reservoirs. These are exactly the types of geological features responsible for major petroleum discoveries around the world. The prospective Arthur Creek Thorntonia Petroleum Fairway extends across approximately 80,000 square kilometres. That's larger than Tasmania, larger than Ireland, nearly the size of Austria, an area that would qualify as a major petroleum basin in its own right. Yet much of this prospective fairway remains only lightly explored. The most prospective region is known as the Toko Syncline. This is where the source rocks became deeply buried and entered the oil window. For millions of years, the Toko Syncline acted as an enormous hydrocarbon factory. Oil was generated, hydrocarbons migrated, potential reservoirs were charged. Later, in the deepest parts of the basin, temperatures became high enough for oil to crack into natural gas. Today, portions of the deepest basin may be gas saturated, and while the basin centre became increasingly mature, the surrounding margins followed a different path. Those regions reached peak oil generation later, and they may have preserved significant oil accumulations. In other words, the deepest parts of the basin may have generated the hydrocarbons, while the surrounding regions preserved them. This is precisely the arrangement petroleum geologists hope to find. The source kitchen generates hydrocarbons, migration pathways transport them, reservoirs trap them. The challenge is proving it. And despite covering an area larger than entire countries, the Georgina Basin remains one of the least tested petroleum systems in Australia, which means the most important question remains unanswered. Not whether oil formed here, not whether the source rocks worked, and not whether the petroleum system exists, but whether somewhere beneath this vast inland basin, one of Australia's largest undiscovered petroleum accumulations is still waiting to be found. I hope you found this as interesting as I did, and as always, thanks for watching. Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.